Good morning. So we are continuing the lesson, that is biomechanics and sports, kinesiology, biomechanics and sports. So today we will discuss about the introduction to work, power and energy. So first we will see then the work. An activity involving a force and the movement in the direction of a force. So work means an activity involving a force and the movement in the direction of the force is known as the work done. It is defined as a product of constant force and the distance moved in the direction of the force. So work done equal to constant force into distance and moved in direction of the force, the displacement we can say. So W equal to F into S. F is force and S is the distance or displacement. The unit of the work is joule. A barbell weight 1000 Newton and weightlifter lifted to 1.5 meter. So work done equal to 1000 into 1.5 and it will be 1500 joule. So this way the work done is calculated. We have studied in the previous topic also about the work. Then next we will see the power. The rate of doing work or rate of using energy is called power. And the formula of the power is work done divided by time taken to do work. And it is also mentioned P equal to W upon T, where P is power in watts and W means work done in joule and T means time taken in seconds. Now this is energy. What is the definition of energy? The energy is a capacity to do work. So there are various forms of energy, but in the field of sports, main concern is about the mechanical energy. So mechanical energy is the combination of kinetic and potential energy. So this energy is used in the ground play field during the sports activities. Kinetic energy is mentioned by the KE, energy processed by the body as a result of motion. KE equal to half into mass into velocity joule. So KE equal to half mv square joule. So this way the KE is calculated, that is kinetic energy. Potential energy PE, energy which is stored in the body because of its position. The potential energy equal to mass into gravitational force into height of the body from ground. So P equal to mgh. So this is also measured in the unit joule. Energy can be transformed from kinetic to potential and potential energy to kinetic energy, vice versa. Then energy transformation is there. The sports we have seen various time the energy transformation is there. So one form of energy is changed in another form of, like the in case of the javelin throw, we can see the pole vault, we can see this is the pole vault jump, energy transformation in pole vault. That is, from initial position, the kinetic energy maximum is being changed into the potential energy maximum. So the transformation of the energy takes place. Now we will come to the another topic, that is friction. So friction is known as an opposing force. This is an opposing force between the two surfaces and when they come into the contact. Friction is very important in case of sports. Friction can be defined the resistance to motion of two moving objects or surfaces that touch each other. Friction play a very important role in many sports such as bowling and curling. There is both static friction and kinetic friction. Two types of frictions are there. Static friction is the friction before an object starts to slide, while kinetic friction is the friction when the object is actually moving or sliding. So we will discuss about the types of the friction also. So always the friction always act in opposite direction of the applied force. It allow us to walk, run, play sports activities. Without friction we cannot make our balance. And maximum friction, when there is no friction we can slip down. When there is more friction, so it is the loss of energy, because that is the opposing force is there. Lubricants reduce the friction, and type of frictions are there: static friction and dynamic friction. Static friction and dynamic friction is divided further into two parts: sliding friction and rolling friction. So this we will discuss them in detail. We can see in the diagram also: static friction, sliding friction, viscosity and rolling friction. So the static friction first we will discuss. Static friction is the opposite force that come into play when one body tend to move over the surface of another body, but the actual motion has not yet started. The opposing force which comes into play when the object does not move over another object, because this is a state position when the body is in rest. Even when the force is applied to make it move, it's called static friction. Means when the body is making them ready to move. Hence it can also be defined as a force which comes into play when two bodies are not moving relative to each other. Static friction prevents objects from sliding or rolling over each other. So static friction is the friction that exists between a stationary object, that the surface on which it's resting. So example, that while we are standing on any surface, while any object is kept over any surface, that time the static friction is there. And even that while we are taking position to run, static friction is there. Once the object starts moving, so it comes in the dynamic, kinetic friction takes place. Then that is the second phase start, that is the kinetic friction. Other examples, when we push a heavy object, because of friction the object is unable to move through the surface. Then we apply some more force on the object. Once it moves through the surface, then it is very easy to move further. Then we will see the dynamic friction. Static friction we have seen. Then we will see the dynamic friction. This is the opposing force that comes into play when one body is moving over the surface of another body. So dynamic friction may be two types. That is, first is the rolling friction. Rolling friction is when opposing force, this is the opposing force that comes into the play when one body is rolling over the surface of another body. For example, wheels, rolling skates. Because these wheels are rolling over the surface, means the one body of the wheel is rolling over the another body of that is surface. So while between these two surfaces the friction is working, that is known as the rolling friction. Sliding friction, the opposing force that comes into play when one body is sliding over the surface of another body. So this way, in this case, the one body slide over another. For example, isoskating. So rolling friction is less than sliding friction always. So examples we can see here. Advantage of friction we will see now. The one upper one we can see, then that is the sliding friction, the rolling friction, and downwards also the rolling friction is there. Advantage of friction: due to friction the object can be placed at position and shaped. Another advantage, that is the frictional force help to move the object by friction. It helps in running, walking. Frictional forces help to move the object with high speed. Example, spikes are used by the athlete to run fast. Stud in soccer, football. With the help of the friction, the wrist of the skin, that is of our fingers and our palm, enable us to grab and hold object. For example, in badminton, the player use grip to hold it. The energy lost due to the friction in trying to move the object is turned into heat energy. So disadvantages are there. Due to friction there is wear and tear of objects. Lubrication is used to allow the parts to move easier to prevent the wear and tears. Greasing is done in the moving parts of bicycles. This is because that is the disadvantage, because it wear and tear of the parts is there. Friction makes it more difficult when one has to move the object. Excess friction can make it difficult to slide a box across the floor while through deep snow. In the roller skating, rolling shoes and smooth surface are used to minimize the friction. Wooden floor used for cycling. Excess of friction means extra energy. Thus, energy is being wasted because the maximum opposing force will allow us to use the maximum energy to overcome the friction. So these are the advantages and disadvantages of the friction. Now we will come to the another topic, that is the axis and planes. Another very important topic. The body perform movement through a plane and around an axis. An axis is an imaginary line about which the body or our limb rotates. It can be divided into three parts. The three parts are there of the axis and plane. First is frontal horizontal axis. The frontal horizontal axis, it is axis of the body that passes horizontally from side to side at right angle of the sagittal plane. That we will discuss sagittal plane further. Vertical axis, axis of the body that passes from head to foot at right angle to the transverse plane. So then the axis is imaginary line that we are saying. So this axis, vertical axis, is passing through head to foot, means head to leg, at the middle of the body, at the right angle. It is dividing the body in two parts, this axis, left and right. So frontal axis, that is dividing the body in two parts, front and back. It is passed to side to side. Sagittal horizontal axis of the body passes from front to rear, lying at front angle to the frontal plane. So this is dividing the body into also two parts, and this passes from front to rear, laying at right angle. It divides the body in two parts, upper and down, bottom. According to these, we will learn the movement. The vertical axis, sagittal horizontal axis we have seen. The frontal horizontal axis, the axis of the body that passes horizontally from side to side and at the right angle to the sagittal plane. Vertical axis, axis of the body that passes from head to foot at the right angle and to the transverse plane. Sagittal horizontal axis, axis of the body that passes from front to rear, laying at right angle to the frontal plane. That what is the sagittal plane? That we will discuss here, then we can understand it more. Sagittal plane, a vertical plane of the body which passes from front to rear, dividing its body to two symmetrical halves, from where it is passing front to rear, and it is dividing the body to two halves, upper and lower. And the planes are the imaginary flat surface along with movement takes place. So then we can understand the sagittal horizontal axis of the body passes from front to rear and dividing the body into two parts. See there, then what is the plane? A plane is an imaginary flat surface along which a movement takes place. It can be divided in three parts again. Sagittal plane, a vertical plane that of the body which passes from front to rear, dividing the body into two symmetrical halves. And transverse plane, any horizontal plane of the body which is parallel to the diaphragm, which called the horizontal plane. Frontal plane, plane of the body which passes from side to side. At the right angle, the sagittal plane, also called the coronal plane. So, sagittal plane we understand first. First is sagittal plane is vertical plane of the body which passes from front to rear. Like that plane is an imaginary flat line. It's passing from front to rear, from front to back, and it will divide the body upper and lower two parts. Transverse plane, horizontally plane, which is parallel to diaphragm, and this is called the horizontal plane that we have seen. The horizontal axis, that is passes to side in previous one. So this is the transversal plane. Diaphragm is the chest muscles which helps in respiration. Then we have another one is the frontal plane, plane of the body which passes from side to side. So it is dividing the body into two parts, front and back. So side to side it is passing, so it is dividing the body into two halves, front and back. Transverse plane, it is dividing the body into two parts, left and right. The sagittal plane, it is dividing the body in two parts, front and back. It is now clear. Now we will come to the type of movement. These movement takes place according to the axis and the plane. The type of movements, physical activity is made possible by the movements and the motion. Every movement takes place in one plane and around one axis. So they are categorized by the movement type as following. So first is flexion. Flexion, it takes place when the angle decreases between two bones attached to a joint, like elbow is there. In flexion we can see the movement decreases the angle between two bones, like we are bending the leg from the knee while you are folding your leg from the knee, then we will see that between two bones, that tibia fibula and the femur, there is the, from these two bones the distance is decreasing, that is the flexion. In hands also we can see from the elbow when we are bending it. So from two bones, that humerus and radius ulna, then we will see then the distance is decreasing. Second is extension. It is just opposite. It takes place when the angle between two bones attached to the joint increases. Both flexion and extension occurs in the sagittal plane about the frontal axis. Another one is the abduction. Abduction is the movement away from the midline of the body. Just understand it. The body is divided. There is the imaginary midline, and the imaginary midline is dividing the body into two parts. So movement away from the midline are known as the abduction. The movement of the right arm to the right side, to the right, and movement of the left arm to the left would be abduction of the right and left arm. It is clear? The movement of right arm towards the right side, because it is moving the away, that is the, it is movement in which movement the body parts are going away from the midline. Midline is there, that is center line. and when we are raising hands up, so this is going away from the midline up to the shoulder level when we are lifting both the hands. That is abduction. And adduction, sorry. Just wait here. This is the abduction. Abduction is movement. The downwards first we have discussed. Now we will discuss adduction. First we have discussed the abduction. Adduction is third one. Adduction is the movement in which laterally towards this is adduction. Just see in the word. The third one is adduction. This is the movement laterally towards the middle of the body. So in which the movement, the body parts are coming closer to the midline. So adduction, when the body movements are coming closer to the midline, in which we can say that while we are bringing hands closer to the body. And abduction is just opposite, in which that just we have discussed, the body parts go away from the midline. Then we will come to the another topic, that is the major muscles involved in running, jumping and throwing. So the major muscles are being involved in running, jumping and throwing. Educating ourselves on the muscles we use while exercising is important. The more we know about our body, the better we can protect it by treating it with care and avoiding injuries. Especially it is very important in the sports and physical activity. Primary muscles used while running. We can see here. Primary muscles will get the most impact from movement and therefore should receive more care. Primary muscles while running will include your quads, quadriceps or femoris, hamstring muscle, gluteus maximus and iliopsoas, and your calf muscles. These are the muscles of the lower body. Primary muscles used while running are the hamstring and gluteus maximus, hip flexor, iliopsoas, calf muscles and quadriceps and femoris muscles. These are the muscles. What are these muscles? Like quads, quadriceps, femoris. Quads are the muscle group of 4 basic muscles located on our front thighs. They are the rectus femoris, the mastoidialis, they are sterilius, and the intermedius. These are the quad muscles, quadriceps femoris. Now the muscles involving in jumping. Jumping, quadriceps, hamstring, hip flexor and calf. Jumping muscles are there. Now the throwing muscles we will see. During the throwing, shoulder muscle, triceps, latissimus dorsi and abdominals and quadriceps. These muscles are mostly common because by the name we can understand. That is the latissimus dorsi, that muscles of the abdominal region. and abdominal muscles and quadriceps. So these are the muscles, major muscles involved in running, throwing and jumping. Now mechanical analysis of walking and running. This we will see then difference between walking and running. Running is the process in which both feet are off the ground. That is the float phase. There is a double swing phase and the swing phase is longer. In comparison we can see then first one, running is a process in which both feet are off the ground, float phase. Walking is the process in which at least one part of the body, foot, remains in the contact with the ground. So running, sometimes the both feet are not over the ground while we are running faster. And walking, at least one leg will remain over the ground. Clear? In contact with the ground. There is double swing phase. Then the swing phase is longer. In case of walking, there is longer stance phase that we will discuss further, but where the swing phase is shorter. Running, the linear and angular velocity of the lower limb is faster. So walking, it is the linear and angular velocity of the lower limb is slower. In running, another difference is running requires greater range of motion and walking requires less range of motion. So mechanical analysis we will see, then we will understand here in detail what is the stance phase. Mechanical analysis of walking. Stance phase. Stance phase is the time when the foot is on the ground. It consists of maximum percentage of walking cycle. For the part of stance phase, both the feet have to contact with the ground. The stance phase of walking is divided into 5 stages. Heel strike, means heel is just striking the ground. Early flat foot, the whole flat is just trying to come over the ground. Late flat foot means the foot is completely resting over the surface. Heel rise, then we'll lift the heel and then toe off. Then the front part of the body is coming down over the ground. Then we will see the stages of walking, that is the heel strike. These we will discuss in detail. The heel strike is foot first touches the ground and continue until the complete foot is on the ground. Early flat foot, second is complete foot is on the ground, that I was telling you earlier in the previous slide. The complete foot is on the ground, and early flat foot stage occurs when body's center of gravity CG passes over the top of the foot. Purpose of this stage is to allow the foot to act as a shock absorber. That's why in case of walking we are comfortable. Late flat foot, body's center of gravity passes in front of neutral position. Stage last when heel lift off the ground. Foot move from being a shock absorber to being a rigid lever, helping to propel the body in forward direction. The stages are there. Then another one is heel rise. Heel rise, heel being to leave the ground, the foot functions as a rigid lever to move the body in forward direction. Toe off, toes have to ground, complete toe toes leave the ground completely. This stage continue until the beginning of swing page. Again the swing page will start. So we can see here how the initial contact is there in first position. Second position we can see the foot flat, and then C we can see mid stance phase, then heel off we will see the D position, then E we will see, that is the toe off, then F we will see the condition, that is the initial or mid swing phase, and then G, that is the terminal swing phase. So the first is A, B and C and D, it is under the stance phase, and E, F and G, these are the swing phases. So this is the mechanical analysis of walking. It occurs when the foot is on the ground and other one is in the air. Swing phases in walking is shorter than the stance phases. That's why that we have seen in difference also. The swing phase is divided into three parts. Initial swing, hip is extended to 10 degree and then going on to flexion and knee flexed to 40 to 60 degree and ankle changing its position from the flexion to neutral. Another is mid swing is there, hip is extended to 30 degree and knee flexion till 60 degree and extended approx to 30 degree and ankle becomes dorsiflexed. Then terminal swing, that last phase previous picture we have seen, hip is flexed till 30 degree and the knee is locked. Extension and foot change its position from dorsiflex to neutral, that we have seen in previous one. Then we will see here heel strike, first one, second image I will show you. Then first one is heel strike, second is early flat foot, then late flat foot, toe off. This is the stance phase, and then swing phase arises here. In the fourth one, fifth one picture we will see the swing phase is arising here, where the one leg is completely leaving the ground, and these are the main joints which move during the walking. Then we will see here the mechanical analysis of running. There is first stance phase. Stance phase is the time when the foot is on the ground. During this phase, the foot and leg bear the body weight. The stance phase of running is divided into four stages: initial contact phase, braking and absorption phase, mid stance phase and propulsive phase. We will see here further stance phase of running, that is the initial contact. After completion of the floating phase, the moment one foot touches the ground is called initial contact and marks the beginning of the stance phase. The other foot behind you is off the flow and is swing phase. Now it is in swing phase. Braking, absorption. Braking means that is the absorption. The moment one foot make contact with the ground in front of you, body is now performing a controlled landing managed via deacceleration and braking. Absorption. Front knee and ankle flex and the foot roll on to absorb impact forces. During this process, the absorption, the tendons and the connective tissues within the muscle store elastic energy for use later in propulsion phase. Then we will see there then propulsion phase. So then we will come to the Another one, that is the mid stance phase. Third one, the braking phase continue until the front leg is directly under the hip, taking maximum load as a body weight passes over it. The ankle and the knee are maximum flexion angle. This moment is called mid stance phase. Then propulsion, when the body is being propelled forward, body weight has gone forward and front foot. Now this foot starts propel you forward. This is achieved by ankle, knee and hip all strengthening to push the body up and forward. Using the elastic energy stored in braking phases, the propulsion phase ends with the toe of front foot, now behind you, leave the ground, commonly referred to as toe off. And you are once again in float phase. That floating is when the person remains into the air. Both legs are off the ground. So swing phase of running, that is the moment of toe off, one leg has travelled as far back as possible and the heel starts to lift. The height the heel reaches and the returning drive of the knee is dependent on the power of hip extension achieved, and it will be greater at higher speed. Stretch reflect mechanism is compared with stretching back of a slingshot and then letting go. Extension of hip is equivalent to pulling back on the slingshot. Letting go result in leg firing forward rapidly, leading with the knee. Once the knee has passed under the hip, the lower leg unfold in preparation once again for initial contact, marking the end of the swing phase. Then again the first position will come. Then figure we will see here some pictures. I will show you. So we can see here, first is the initial contact phase, mid stance stage, and propulsive stage when the person is propelled forward. The flight stage is the initial swing phase, downwards first, and swing phase, that is the mid swing phase, and then terminal swing phase, that is the downward third. So this is all about this chapter. We will come with the next chapter in the next video.